This episode is brought to you by the Spirit Plant Medicine Conference happening in Vancouver, BC from November 2nd to the 4th. I love this conference and the community of people I have met there over the years, and so I'm very excited to be attending again this year. Some of the main speakers include former guests on the show Elizabeth Bast and Dennis McKenna, as well as others like Paul Stamets and Wade Davies. Head to jameswjesso.com/SPMC, which stands for Spirit Plant Medicine Conference, for more details. Again, the link is jameswjesso.com/SPMC. Hey everyone, welcome to Adventures Through the Mind. I am your host, James W. Jesso. I'm filming this intro inside of my living room today just because I'm feeling a little stuffy in the office and was having some video lighting complexities, the learning process, not always so comfortable. So yeah, if you're watching this on YouTube, you get to see an entirely new, different space in my house, but that is besides the point. Today we are interviewing Selen Atasoy. Selen Atasoy obtained her PhD in medical imaging jointly at the Technical University of Munich and Imperial College London. She then held a postdoctoral research position at the School of Psychology, University of New South Wales, Sydney, where she started her work in experimental and computational neuroscience exploring neural correlates of consciousness. Then she moved as a postdoctoral research fellow to the Center for Brain and Cognition, Universitat Pompeu Fabra, Barcelona, and worked with Gustav Deco, Joel Pearson, and Martin Kringelbach on neural correlates of different states of consciousness. Currently, she is working as a postdoctoral researcher at Hedonia Transnational Research Group, University of Oxford. Her current research focuses on exploring brain dynamics in consciousness, sleep, meditation, psychedelic states, as well as in psychiatric disorders by analyzing fMRI and MEG data within the mathematical framework of harmonic waves, a phenomenon ubiquitous in nature. Connectome-harmonic decomposition of human brain activity reveals dynamical repertoire reorganization under LSD. That is the name of Selen's research paper on the topic that we're going to discuss on the episode today inside of the lab of Robin Carhart Harris. It's a pretty complex name, and in all honesty, it's an extremely complex topic that I don't think I can fully or properly recapitulate in a simple statement. Thankfully, Selen does an incredibly good job of representing this data both accurately and simply for, I know some of you are cognitive neuroscience scientists that listen to the show, but a lot of you are not, like myself. So it was really great to get the hard data and the complex topics and to also have it boiled down in a way that made it easy for me to understand and hopefully you to understand as well. Before we get into the interview, I'd just like to send a huge thank you to my patrons on Patreon. Thank you for producing a reliable income for me on the merits of my work and on your support of it. A specific thanks goes to the people whose names are listed in the description to this episode, as well as in the upper corner of this video on YouTube. If you, the listener now, would like to become a patron of the show, which is to say that you would like to commit or pledge a certain amount to be sent to me once a month for producing this podcast and my other work, and have some sort of bonus material given to you as a thank you for that pledge according to the amount that you pledged, kind of like a subscription service, well, that'd be great. And I'd love you to do that. You can do so by heading to patreon.com/JamesWJesso or by checking out the link in the description to this episode. Quickly, one other way that you can support is by buying copies of my books, The True Light of Darkness or Decomposing the Shadow, which are about the potentials, spiritual and psychological potentials of working with psilocybin as an ally in emotional healing and maturation. You could also buy one of these fun blotter arts that were produced for the podcast that are limited edition. There are no drugs on it. They're definitely for hanging on your wall, not putting in your mouth. Be it Patreon, PayPal, crypto, or some sort of merch, I really lovingly appreciate your support of the podcast. All right, into the interview with Selen Atasoy. A quick point to consider before we get into it. This podcast interview doesn't start the way that interviews typically start, where I say, "Hello, Selen Atasoy, welcome to the show, blah 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 blah, here is your bio, here is the first question." It just kind of started that, I asked her for sound check, like, "Hey, what have you been up to this morning?" to check the sound. The sound was on, and what she was up to was something that was really relevantly interesting to me at the time, and is actually directly related to the episode that came a couple before this particular episode, the one with Stephen Gyllenhaal about epigenetics and unconscious memories from fetal development. Anyways, we get into the actual topic of her research around fMRI data and of psychedelic states after the first few minutes, but just so that you're aware, we're not starting this podcast slowly and progressing. We are just jumping into it. So I hope you enjoy. This is my interview with Selen Atasoy on Adventures Through the Mind. Enjoy. How are you doing today?
Yeah, good so far. Was attending a talk in the Department of Psychiatry about PTSD and alcohol abuse and the underlying genetic factors. It was interesting to get different perspectives.
Curious about your thoughts on this underlying genetic factor in specifically using alcohol for PTSD, or like a susceptibility to PTSD.
It's very in line with the question that I asked, because this is not my research field. And I think it is more the susceptibility and the vulnerability of the individual. But it was quite interesting to hear that in the end, the speaker actually mentioned that this is all covariance. So there are individuals who actually have these genes that are thought to be associated with this vulnerability or susceptibility, but do not develop this kind of disorders even though they're exposed to trauma. So there's quite a bit of a playroom.
Interesting. Is there any influence there, or like possible consideration towards the impact of environmental conditions for an epigenetic alteration of like those particular issues?
I'm not quite familiar with the research. I know there's a huge epigenetic research going on at the moment. And also I was mentioned, there is this now recently the research about resilience and the factors of resilience also is picking up quite rapidly. And that includes the environmental factors as well as the genetic factors. But it could be that the psychiatry is rather focused on the genetics. But I'm sure in psychology and other scientific circles, there's a lot of research going on about the environmental factors as well.
Mm-hmm, mm-hmm. Yeah, I actually just a few days ago interviewed somebody who produced a documentary specifically about the epigenetic impact of environmental conditions of the mother on the developing fetus during gestation. And there was evidence, I think it's through mouse models, but then there's, I believe, evidence in humans as well that environmental stresses can actually modify the way the genes express, so that an infant who goes through some sort of uteral stress is more likely to develop stress-related illnesses later, such as post-traumatic stress disorder.
Yeah. It's very interesting that you mentioned that, because we did have a discussion about that, just a casual discussion within our research group, and how important it could be, how important the environment of the fetus is actually is because this is the stage, the phase that we are undergoing probably the biggest change and development in our lifetimes, and it only makes sense how influential the environment can be. So it's always a big question, I believe, how much of it is nurture and how much of it is nature, and there seems to be evidence for both. So it would be a little bit of a half a story to tell it's only nature versus it's only nurture or the environment. So it seems like the interplay of the two, but it would be quite interesting to identify the most crucial factors in both, I would say.
Mm-hmm. Yeah, I would definitely agree. And then I'd also extend that sort of the false dichotomy of nature versus nurture towards the false dichotomy of body and mind even, and that there's some sort of differentiating factor other than simply by nature of I'm looking at the body now, and that being the differentiating factor to I'm looking at the mind now.
Yeah, fully agree. So we always my research focuses on consciousness and its altered states from a neuroscientific perspective. And there seems to be a gap between the brain and the mind. So you are either, you think it's the brain that is causing everything, or there are people who believe it's the other way around. And it's sometimes feel a little bit of an artificial type of separation that the brain and the mind like the body and the mind in a similar way. So it could be the reflection of that just two different aspects of the same thing in a way.
Mm-hmm. Yeah, it reminds me, I think it was Bernardo Kastrup, who's a philosopher of mind, and him talking about the neural correlates of consciousness insofar as his sort of larger ontology of idealism or modern idealism. And he makes a good point, which is that it's easy to confuse causation or with correlation.
Mm-hmm. Well, I think the reason that term was coined in neuroscience in the first place is that there was this huge debate about consciousness and if the brain causes consciousness and how it does so and so on. And it to start with, it seemed like too big of a problem, the causal links. So it was in a way easier to study the neural correlates of different states of consciousness like wakefulness, sleep, psychedelic states, and so on, and hoping that with those insights that we gain from those studies, then we may ask new questions based on those findings. So it was a bit of an initial step, I think, towards the bigger picture.
Mm-hmm. And the neural correlates of consciousness is what we can see physically operating in the brain in reference to what is reported as subjective effects.
Yes, exactly. So in the consciousness research, generally there is this distinction between the state and the content of consciousness. So you can either go around studying what the subjects report, for instance, showing them a brief stimuli and asking them whether they have seen it, and what they have seen that would relate to content of consciousness. And depending on how long the stimuli was displayed, the subjects may be consciously aware of it or not. But what's my research is rather focusing on is the state of consciousness, where we distinguish between different states, such as wakefulness would be the most familiar to all of us, wakeful conscious state that we assume we are all conscious. And then different stages of sleep, which I like to refer to as an altered state of consciousness. Actually, I mean, especially the dreaming states, there's at least a subjective experience going on. And then we recently looked at the effects of psychedelics, and that would be another altered state of consciousness, or even meditation could be considered as an altered state, as the conscious experience is significantly changing in that state. And then looking at the brain activity and what changes in the brain activity in these different states of consciousness, and maybe trying to find a possible explanation or a framework to work with to explain the differences that we see. In brain activity. Yeah.
And one of the ways that the approach that you and your team are wielding as you're looking at these different brain states is something that you call the I got it written down here, connectome-specific harmonic waves. Yeah.
Yes, exactly.
Maybe I would like you to explain that, because it sounds awesome and also sort of a little deliriating to some degree as well, because without any context for what you're talking about, it just sounds like a cool word with no real understanding, right? And the conjecture could just just fill in really fast with these fun words. So maybe you can start with giving just a general look at how conventional, or we'll say conventional fMRI research is approaching the analysis of that data in regards to brain states, and then utilize that as a reference point to explain this approach that you and your team are doing with the connectome harmonics.
Sure, I think it's quite an important point, because it can easily turn into a buzzword without really understanding what it means. So the very basic state-of-the-art analysis, for instance, looking at the functional magnetic resonance imaging data. So in the last decades, it used to look at brain activity as activation in certain brain regions. And that was mostly related to a certain task. People were asked to perform a certain cognitive task in the scanner. And then the brain activity was analyzed in terms of what was happening before the task and during the task, and which areas increased their activity, and so on. But in the last 2 decades, that started to shift to what is called the resting state analysis. And that was mainly due to the discovery of the fact, or the observation, that resting state brain actually shows very organized spatiotemporal patterns. It's definitely not purely noise or just a random brain activity, but there's a structure to it. And that opened a whole new line of research based on resting state fMRI data. So that can be like an intermediate step that can be seen as an intermediate step towards brain states in a way, because what people have discovered is there is correlated activity in the brain. And what I mean with that is, for example, if you were just take an example seed location, seed voxel in the brain, and look at its correlation with the rest of the brain, you would see that distant parts of the cortex actually show synchronous activity over time. And that has certain structure to it. So this is how neuroscience literature started to identify what's called the resting state networks. So these are distributed parts of the brain which actually show synchronous or correlated activity over time.
And this is related to what is often talked about in psychedelic neural research, which is the default mode network, right?
Exactly. Default mode network would be one of these resting state networks, and actually quite an important one, because it has some remarkable properties and has been intensively studied in the literature. What is quite special about that particular network is that it actually increases its activity when you're doing no task, no cognitive load. And the opposite is true. So it's also referred to as task negative network in some cases. And I think psychedelic research is also intensely focusing on the changes in the default mode network, and also other altered states of consciousness. It has been reported that default mode network actually changes its either structure or strength in deep sleep or in anesthesia. So default mode network is quite an important one, but there are other networks as well, and the other ones generally overlap with the functional networks of the human brain. So these networks that we can identify in the resting state actually have functional meaning when we are performing any kind of task. So the way we actually started exploring the idea of connectome harmonics was when we wanted to study the link between the structure of the human brain and these type of patterns. So it seemed like brain is kind of creating these distributed patterns throughout the thalamocortical system or throughout the brain. And we know they are constrained by the anatomy, by the structural connectivity of the brain, but we didn't quite know how. And the intuition actually came from music, and maybe I don't know if everyone is familiar with this idea of the Chladni plates, the sand patterns, where in the 18th century a musician called Chladni spread some sand on the metal plate, and then he let the plate vibrate. And the sand starts forming these very complex shapes on the metal plate. And this is because anything that can vibrate, including a simple metal plate, has certain preferred frequencies called its natural frequencies. And if you excite it with one of these natural frequencies, it's going to resonate. So, and in that resonance, it will create this standing wave pattern where certain parts move up and others move down, and then they swap. So it's a standing wave, not a traveling wave. And the sand accumulates at the boundaries of the regions that move up and down, so at the stable points, and it forms very complex shapes, but it's kind of a self-organization once you excite the system with that.
And this is what some of my listeners might be more familiar with as being called cymatics. Yes. Exactly.
So it then evolved to be the cymatics, and that was, I believe, the initial experiment that led to the emergence of the whole field on that. So what was quite inspiring about that was, so we know about brain activity that there are temporal oscillations, and these oscillations really cover a very, very wide range of frequencies. And now in the last 2 decades, neuroscience has discovered that there are these distributed patterns of synchrony, patterns of correlation. And we know that both are kind of constrained by the anatomy of the human brain. So when we look at that type of a puzzle, the pieces of the puzzle, we have the temporal oscillations and spatial networks, and we have the anatomy of the human brain. And it was a bit of a maybe crazy idea to take it as an inspiration, but this cymatics or this metal plate example kind of matched the puzzle. So it was oscillating over time, creating distributed patterns of correlation, these sand patterns, and it was adapting naturally to the shape of the metal plate. And actually there's a study which is not maybe that well known, but I really, really think it's a very, very interesting study by Murray and his colleagues, where they cut the metal plates in shape of animal skins, and they captured the vibration modes to the shape of the standing waves. And so, of course, for different frequencies, the shape changes, and it also adapts to the this time anatomy of the animal, so the shape of the metal plate. And they showed that they resemble different types of animal coat patterns. And that is not actually a coincidence or a surprise, because there are various types of dynamical models looking at how animal coat patterns emerge. And it turns out that these standing waves, or these what we call the harmonic patterns, also provide the building blocks of this type of biological pattern formation and morphogenesis. So kind of linking all of these findings together, we hypothesized, what if similar type of equations were actually governing brain activity as well? What if these type of harmonic patterns, when they emerge on the brain, could predict some of the networks that we see in the human brain? So we tested that in our first study when we coined the term connectome-harmonics, because it's literally the very same equation that would predict the animal coat patterns or their building blocks, or these cymatic patterns or the Chladni patterns on the metal plates. So it's exactly the same equation, but this time solved on the particular structural connectivity of the human brain. So we called it connectome-harmonics. And we really weren't sure if we were going to get anything. It could be just a similarity. But very interestingly, that we did find specifically the default mode network very consistently within the same frequency range across different subjects. So, and then when we did all the statistical analysis, it was quite significantly matching. One of the connectome harmonics was quite significantly matching the default mode network. And when we looked at other networks, it turned out to be a combination of the harmonics, of the connectome harmonics. So it was more like the low-level sensory networks were matching combination of a few low-frequency connectome harmonics. And the higher-level cognitive networks, like attentional networks, required a broader range of harmonics to be reconstructed in a way. And
so wait, can we pause for a second, because I want to make sure I'm understanding something.
Sure. Yeah.
So you looked at all the different fMRI data that you had for the different resting states that were happening in the brain and the specific connectome, so the specific structure of connections that are awake or alive during those resting states, and then ran this algorithm that assesses harmonic waves through those structures to figure out what frequencies, what frequencies, wow, this is really complicated, created a type of standing wave, or like created a type of specific system of activation in the brain, and then mapped those. And then
it's actually simpler than that.
Okay.
Maybe I explain it step by step. It can sound complicated, but actually it's not. So we took the human connectome, which is the structural map of all the long-distance white matter connections of the human brain. So these can be seen like these highways connecting distant parts of the cortex. And then we also reconstructed the brain, so the shape of the gray matter of the brain. And so we created a detailed map of the anatomy of the human brain, which included the gray matter connectivity, so the structure, the anatomy of it, and these highways, these white matter connections. So that gives us kind of a structural description. And instead, it's very similar to, so the simple version of that would be the metal plate. Instead of having like a rectangular shape or an animal, the animal coat type of shape, we have this complex shape given by the human connectome. And then we simply compute all the spatial patterns of standing waves that would emerge, like theoretically that would emerge on that particular structure. So we are not yet using any fMRI data at that stage. So we are creating a set of patterns that would emerge as standing waves or harmonics on that particular structural connectivity.
Okay, yeah, that makes perfect sense to me now.
And then we looked at the default mode network and other networks that were published in the literature by other studies. And we mapped them on the cortex that we used. And then we looked at the similarity of each of the patterns that we compute as the connectome harmonics and each of these networks. So it was more or less a prediction in a way, like these are the synchronous patterns that would emerge on this particular structure. Do they match any of the networks that are reported in the literature? So that was the first study to kind of test the hypothesis if there was any meaningful information in these harmonic patterns. And later on we extended that to look at the fMRI data in a different way, and this was also recently applied to LSD dataset. And maybe just to briefly explain how that works, because in the first we just compute these harmonic patterns and then we look if they match any of the networks. But there is something quite important about these harmonics, because altogether, like technically you would have infinite many harmonics. And we are using around 20,000 connectome harmonics, and that's determined by the resolution of the data that we have. So the set of all of them actually creates a new coordinate system, a new language, so to speak, to represent your data. So we can take any fMRI data set, or actually even other modalities, and just transform it into this new representation. So instead of having voxel by voxel, like different temporal activity over space, we can actually transform it into this new harmonic language where we say how much of the first harmonic is present in my data at this time, how much of the second is present, and third, and so on. So that's kind of a change of perspective or change of representation. But it can provide certain advantages because you are now working in the frequency domain and over time. And so we are in a way only changing the representation of the data into this harmonic language, but we can ask different types of questions in that language. So we can ask the power or the energy of each of these harmonics, and we can treat them as different brain states emerging and disappearing over time. And then we can analyze any fMRI data sets in this new representation. And this is what we did with the LSD data set.
Well, I have a couple questions that have to do with how interesting the concept of observing brain states and brain activity from the vantage point of frequency and harmonic waves, given some sort of ancient spiritual teachings around the structure of reality, the structure of mind, the structure of life being harmonic at its essence, as well as some of the interesting implications there for a quantum understanding of brain function, or a capacity of looking at the brain as a series of vibrational patterns or waves. But before we go there, why don't you tell me about what you found when you gave people, I don't know if you gave people LSD or you just took the LSD fMRI data, but what did you discover? Maybe clarify that, and then what did you discover is unique about the LSD state insofar as these connectome harmonics?
Sure. So we were lucky. We just got the data from our collaborators at Imperial College London, from Robin Carhart-Harris and his group. So we took the fMRI data and we ran the analysis on that. But so it was actually the first time that we applied this type of harmonic decomposition onto fMRI data. So we really didn't know if it was going to give us any meaningful information.
Wait, can I pause you there for a second? Because
Sure.
I think you just used a word that I don't remember being properly explained yet, but I did see it explained in your lecture, which was really cool, which was, you said harmonic decomposition. Could you give us an idea of what you mean by that before you continue?
Sure. It's exactly what I described in terms of translating the data into this harmonic language. So instead of looking at the fMRI data as values over space and time, we simply transform it into this harmonic language, in that we ask how much of the first connectome harmonic is present in my data at, let's say, time t1, and how much of the second is present. So in a way, I'm computing the contribution of each of these harmonics in order to create exactly the particular shape of the brain activity that we measure in fMRI.
Which is not too dissimilar from looking at a piece of music that is in and of itself its own thing, and then decomposing the specific notes to grasp what sounds are being made.
Exactly. I really like this musical analogy because it's more than an analogy given the details of our technique. So these harmonic patterns, they emerge every time we play a musical note or a melody within a musical instrument. So these standing waves emerge. And what we do is, as if we take a snapshot or a video of these standing waves emerging within the musical instrument, and then we decompose it into different musical notes because we in advance compute the standing waves of each musical note or corresponding to each musical note. So it's really asking the question, what kind of music is your brain playing in different states of consciousness? So we take the fMRI data as our complex melody or complex musical piece, and then we decompose it into the combination of these connectome harmonics, which would correspond to the musical notes.
That's a beautiful picture, actually. Like thinking about the ever-flowing continuity and complexity of my subjective awareness being like a musical masterpiece that I'm composing over time. Yeah, that's a really nice image. Thanks.
I think it really gives a simple, intuitive understanding. I find it really, I started to find it more intuitive looking at fMRI data or brain activity that way than the current state of the art or the normal analysis. But of course, I'm using that method quite a lot now. So when we looked at LSD fMRI data using this type of harmonic decomposition, let's call it, so first of all, we did look at different properties of that. So one of the things, when you describe the data in this frequency domain, one of the things that you can look at is its power or the energy. So how much energy is there present in one connectome harmonic, or how much energy is present in the whole brain activity. And quite interestingly, we found that LSD actually increased the total energy and the total power of brain activity. And maybe to explain the difference between energy and power, because they actually refer to more or less similar properties, but with the power, we mean the amount of contribution coming from one particular harmonic would be the power of that connectome harmonic. But generally in these type of frequency analysis, what happens is that low frequencies have really large power, and you don't get to see the effect of high frequencies as easily if you're plotting them in the same axis and so on. So in order to be able to extract also the effects or the changes in power in high frequencies, we also looked at what we call the energy. And energy is only a frequency-weighted version of the power. So instead of just simply using the power, we multiply it with the intrinsic energy of each connectome harmonic. And that intrinsic energy is higher for higher frequencies. So the higher the frequency, the higher is its intrinsic energy. But so in a way, energy could be seen as a frequency-weighted version of the power. So in our analysis, we observed that both actually significantly increased under LSD. But the maybe more striking findings came when we looked at different frequencies. So what was going on when we looked at the power or the energy of different frequencies was that LSD was actually suppressing the activity of a narrow range of low frequencies. And these are actually the frequencies where we significantly found the match of the resting state networks as well. But for a very broad range of high frequencies, we observed an increase in energy or increase in power equally under the influence of LSD. So it kind of was altering brain activity in a frequency selective manner.
Do we have any references for what those higher frequency states are? Like, do you have anything that you could point to that's a non-LSD state to be like, oh, this particular frequency is present in this other state, and we saw it get amplified with the LSD?
So one thing to note probably is that due to the nature of this technique, that we assume that all frequencies are more or less present. They can technically be present in any state, and we are looking at whether they are or how much they contribute to it. So the high frequencies would be patterns that are more localized and more distributed throughout the brain. So if you, for example, think of cymatic patterns or these sand patterns forming on metal plates, when you change the frequency, that naturally changes the shape of the sand pattern. And if you look at different frequencies, you would observe that low frequencies would be these more global waves emerging on the metal plate. And the higher the frequency, the more complex and the more distributed is the shape of the standing wave. And that is also true for connectome-harmonics. So the low frequencies would be like one wave passing through, maybe separating the two hemispheres or passing from frontal cortex to the back of the brain, and so on. And the higher the frequency, the more localized the waves become. So they not only localized, but really more distributed and more complex if we look at them spatially. So higher frequencies, we can say, have more complex spatial patterns, which are more distributed in terms of space. And so maybe another intuitive way to look at it would be to see something, it's very similar to another concept that is very well known in mathematics and physics as the Fourier transform or Fourier decomposition, where you can actually represent any signal as a combination of sine waves, very simple sines and cosines. And in order to have a sharp representation of a complex signal, you have to include also high frequencies. So the more complex your signal is, and the more detail you want to include in your description, the broader the range of frequencies that you would require in a way to create that particular signal. And that's also true for the connectome-harmonics.
So, and please definitely correct me if I'm misunderstanding, but your research is suggesting that LSD creates an increasingly complex brain state?
Yes, but I wouldn't conclude that only based on the finding that it's actually increasing high frequency activity. We did conclude that based on another finding, actually, which is more suggestive of that, and that was the number of harmonics that contribute to brain activity under LSD were more than in the placebo condition. So, and actually we do like to use the musical analogy on that, because there are studies which have found that improvising jazz musicians play significantly more musical notes during improvisation compared to memorized play. So following that analogy in terms of connectome-harmonics in the brain, we actually find that the brain is activating more of these connectome-harmonics at the same time in order to create these patterns of brain activity under LSD compared to placebo. So more harmonics are active, and more of the high frequencies are active. So based on these observations, we can actually conclude that it's increasing the complexity of brain activity.
Sort of like, and this is then also correlated with the increased subjective richness of the LSD state, increased sense of, visual, auditory, tactical sensation, as well as complexity of thought narrative. All of those things seems to increase subjectively into an increased sense of richness in the LSD experience. And do you think that those things are correlated?
I think, well, they are certainly in line. So the subjective experience becomes in a way richer in the psychedelic state, which we also observe in brain activity in terms of its harmonic states. But we haven't done any kind of statistical analysis on if there is any correlation between the intensity of richness and the number of brain states that we observe. But we did find actually a quite interesting correlation and a significant correlation between the suppression of the low range of connectome-harmonics, the low frequency range, and the experience of ego dissolution, so the experience of feeling no boundaries or feeling one with the universe. The intensity of that experience that the subjects have reported after their LSD scan actually correlated significantly with the amount of energy that the low frequency range connectome-harmonics lost during the LSD experience. But I think generally there seems to be a parallel between the richness of experience and the richness of brain states. And if we were to evaluate it statistically and we found significant correlations, I would certainly be not surprised. But we haven't done it yet.
There's another important concept that seems to be emerging in the larger sort of brain research on psychedelics, and in particular LSD, that you speak about in your lecture at Psychedelic Science, which is criticality. Can you maybe outline what that is and then place it in reference to what you've told us about LSD is increase in brain energy and power and the presence of high frequency standing waves in the brain?
Sure. Yeah, I think criticality is also quite an exciting concept. So I'll try to explain it rather from an intuitive understanding. So criticality is this kind of special type of dynamics that seem to occur just at the transition between an ordered regime and a chaos or disordered regime. So if you were to change a variable in your system, that is very similar to like a phase transition, and people usually refer to, for example, ice melting. So if you were to increase the temperature, you wouldn't see any structural changes in the ice until you reach the critical temperature of 0 degrees where it starts to melt. And that is the type of behavior that we also see at critical dynamics. So nothing is changing until the critical regime is reached. And just at that transition, there is a sudden change is happening. So there's a reorganization occurring at that particular value of the variable. In that case, it would be temperature. So what is interesting about criticality is just it's at the transition, at the border between order and chaos, or order and a less ordered organization. And in the example of ice melting, so for instance, ice would be the ordered organization and water would be less ordered or rather chaotic. Well, not really chaotic, but in that example, less ordered state. And criticality has certain type of signatures. If a dynamical system, like a system that is changing over time, is close to criticality, then we would observe certain characteristics in the relationships between different observables. And when we look at fMRI data, we do find these type of signatures of criticality. And I would say it's quite important to note that it's not only under LSD we find them. We already observe some signatures of criticality, or the kind of signatures of criticality with some accuracy, even in the resting state brain activity. But under LSD, these signatures are really enhanced, and some characteristics may even change. So our findings when we look at criticality in brain activity seems to suggest that LSD is actually tuning brain activity further towards criticality. So you may be just close enough to this melting point, but when you're under the influence of LSD, your brain activity seems to be rather closer to criticality. And I think when I started studying criticality, I found it really helpful to look at it from an intuitive perspective as well. There's quite a few books and quotes written about understanding criticality, and it has been even said that it's like a constantly shifting battle zone between stagnation and anarchy, so between order and chaos or less order. And or it can be also compared to the life emerging in the shallow waters, where you have the land and the deep sea water, and just at the transition there's a richness, there's a combination of the two. There's a certain element of stability and flexibility. So if you think about the brain and about cognition and our daily experience even, we need certain amount of stability in order to function. But to have a rather rich life, we also need, and even to adapt to life in general, we need a certain amount of flexibility. We need to do sometimes things that we haven't done. And that, I think, is quite an important aspect of criticality, which may also have big consequences for psychiatric disorders and how to look at them in terms of brain activity being at criticality or close enough to criticality and so on.
It also would have interesting, the idea that LSD, and I'm assuming we'll find out other psychedelics bring the brain into a state of criticality, would be part of why they might be so therapeutically useful if we look at the structure of the mind being like a block of ice, and somebody who is suffering from an intense mental illness such as major depressive disorder, that ice is like, say, a non-functional shape. It's just not fitting into the cube or something. And so, but it's very difficult to change because it's just locked in this shape. And then that criticality on the psychedelic, it's like, oh, as it's melting, depending on the environmental context, the melted ice cube and sort of the residual water could be formed in a different way. So as the psychedelic, its metabolism wears you back down into baseline, it can sort of refreeze in a more functional shape. Does that sound accurate?
Yes, I think it's a very beautiful way of looking at the. I mean, it's an analogy, of course, but I think it's a quite important one, because, like you said, it can be that the pathways that are created and the brain activity. Well, take for example depression. A person who is suffering from depression may have created thought patterns that are no longer serving that person, but the person may not be able to change them so easily just from one day to the other. Okay, I'm just going to change my thought patterns from now on, because there is this, our neural activity also shapes our brains. So it is not only one way, but it's like a loop. Our brains create our neural activity, but neural activity in turn shapes the structure of the brain. So it is not an easy jump to change from this to that. But the way we generally talk about, or again using another analogy, is that if there's a landscape, let's say, and the landscape of all the states of brain activity, and let's imagine there's a deep valley and there's a ball which is exploring the landscape, so that would be your brain activity exploring all the possible states. And if there's a deep valley, deep gap there, the ball may get stuck in that valley, and no matter how much energy it has, it may not be able to just get released from there. But then imagine flattening that landscape. The landscape becomes rather flat, so the ball is released and can explore more freely. And that could be a useful way to look at what is happening to brain and to possible brain states under the influence of psychedelics. They seem to, because more brain states contribute, or there seems to be new combinations emerging in terms of brain states, and so this landscape is becoming rather flatter in a way, and providing a possibility for the exploration of the new. And I do think that that may be a useful way of considering the therapeutic effect of the psychedelics.
Mm-hmm. Yeah, I've heard a similar metaphor with in regards to skiing, and it being like the hill is like really packed down, but then after psychedelics, it's like you have a fresh powder day. So you get to choose the new paths that you take down the hill. Another thing,
That's a nice one too. I haven't heard that one.
Yeah, well, it was actually a friend of mine who's deep in psychedelic research and runs a ski lodge gave me that one, so it makes sense.
Okay. Yeah.
So another thing is that what you're talking about here is it's neuroplasticity, is it not? How the brain changes in response to what we do and how we use our brain in a feedback loop, that we're more likely to do things that the brain is good at, that it's more likely to be good at because we're doing it, and can be a very detrimental vortex, but it could also be a very positive one. Is that and so that also brings up the suggestion that psychedelics could increase the brain's capacity for laying new neural foundations on the principle or its ability for neuroplasticity. Does that fit?
I think it's quite interesting and important, but it's is really not in my research area. We haven't done any studies on changes in structural connectivity, and I'm not aware of psychedelics effect on the changes in the structural connectivity. I think it would be a definitely very interesting study to conduct, and definitely would provide us more insight whether this analogy of the belly and the gaps in the belly and the landscape of brain states is really linked to neuroplasticity, whether it's actually having lasting effects on the structure of the brain. But if you even think about in terms of experience, if a person has never been able to have a certain type of experience, and then by flattening the landscape even temporarily, you enable the emergence of that experience, or that person having that experience, even just that very one instance, and the things they conclude based on that instance may have influential effects in the longer term, I believe. But I think scientifically it would be definitely very interesting to look at the links of psychedelics to neuroplasticity.
Well, given the increasing progress of the research, I don't doubt it'll be not too long from now that we'll get to see that official research. For the last few minutes that we have to talk here, I want to ask you some questions that are inviting you to play with conjecture. And so to the degree to which you're comfortable doing so, please do. And to the degree in which you are not, please deny whatever question. I'm curious about what I mentioned earlier around looking at the brain as a physical organ, as well as obviously an organ that is related to subjective experience. So thus our experience of self and of reality, very mind things, as being something that operates in frequency and harmonics. And then looking at things like ancient spiritual or religious traditions that look at reality itself as a type of energetic system. I'm just curious what your thoughts are on that, because when I mentioned it earlier, you kind of had this like, oh yeah, smile that came up for a second. So I don't know where to ask you to go here because I don't know where you're at, but just what are your thoughts on this?
Well, I think it's kind of a quite interesting overlap, and I personally am a curious person who is to some degree also skeptic generally. I would like to understand and see in the way it makes sense to me, of course, being a scientist. But I don't like to dismiss any kind of information or data as that's, I shouldn't take that into account. So our motivation in starting with the harmonic analysis was following rather the study of finding these morphogenetic patterns and how they are actually described with harmonics, and also seeing the similarities between music and all of that. but it is, well, it is apparently also the fact that most spiritual traditions also refer to vibrations and reality. I would, at this stage, as we haven't conducted any studies, I would rather shy away to point any kind of observation. Well, this is how it's working, and so on. As I think probably no one has quite figured it out. But I also wouldn't dismiss such a huge ancient knowledge and traditions and oral traditions like in yogic cultures and so on. It's certainly, we did come from a different point of view, but I personally think that because of these links, science shouldn't shy away exploring these possibilities. But having said that, also shouldn't jump ahead to go there before we find evidence or an understanding, because we may be losing on quite important insights along the way. In the end, we don't know whether we are going to end up in the same findings as described in those ancient traditions. But even if so, I see the value of the scientific methodology in terms of taking one step at a time and asking the right questions, and also being allowed to be surprised by the findings, because that always creates new questions. So I think it's important to keep an open mind and curiosity, and I mean it in both aspects, not being too skeptical in the sense that I wouldn't even do the study if that's the way it is, and there's a split between science and other ancient traditions or spirituality. But also the opposite can be also true. So you may want to just go ahead and you know what you want to find and look for it, rather than just doing the study with an open mind and being open to whatever it tells you. Because that may be a temporary state, and then you may ask another question and another and another. So I find it quite playful and see the value in finding the balance between open-mindedness and skepticism in that sense.
Yeah, excellent. I'm totally on board with you there. That said, I fully embrace my capacity for wild conjecture, because I am a writer and a public person, but not a scientist. So it's at no harm to my career in any way to go far off the edge. So I want to maybe present to you some of the things that your research called back into questioning for me, or at least what I got out of your research.
Sure. Yeah.
One of which, and it's going to tie back to the ancient traditions in the last part, but the middle part is this, which is that you notice that there was a specific influence from music on the LSD and on the placebo brain, and that there is some sort of impact on we'll just say the harmonics of the music on the harmonics of the brain. And I'm curious what your thoughts are, because those harmonics can be represented in sound. They could also be represented in light, on things like binaural beats or brainwave entrainment, and how we could influence different subjective states by inviting the brain into muting certain frequencies and increasing other frequencies, such as I've seen some promotion around this supposed machine that many people are saying works, which uses light frequency to induce a DMT type experience.
Oh, really?
Now, you don't have to comment on that specific machine, but having presented that idea that external frequency patterns can influence intersubjective experience, particularly music, maybe light. Can you just talk on that for a minute?
I think it's an excellent view, really. And I think it's quite an important one, because in the end of the day, we are searching for certain states, and it's so I can say that our music study is rather on the way to look at the effects of music on the brain and relating. But I really like the idea of relating the harmonics of the music to the harmonics of the brain. And if we are going to see any correspondence, that would be definitely a very, very interesting study to go on. So I wouldn't be surprised if there. I'm sure, like when you look at, for example, the meditative state, and different types of meditations, they seem to induce also a certain type of altered experience. And I recently was told that certain type of meditation, which involves mantras and sounds and so on, can also induce an altered state of consciousness. So I wouldn't know how exactly it works, or how we can in detail study that, but it's stimulus like a sound or a light creating certain patterns in the brain. That's not news, that we already know that our brains are in constant interaction with the environment. And the way we looked at it so far was in the resting state, eyes closed condition. But in LSD, we did have one music condition, which we didn't distinguish so far in terms of trying to find the effects of music as a separate variable. But I think it's a very, very interesting perspective. And I would be very eager to research on that more. We should probably rather think about the details of how it can be scientifically studied. It's if you think about, like, sound is a wave, and creating a pattern of a standing wave or a vibration in the brain, as we can now decompose into or measure. There must be a link between the incoming stimulus and the types of harmonics that are evoked with that stimulus. So the meditative state would be rather as like internal activation of those states, but I think it's even easier to evoke them rather probably externally and through possibly through harmonics as well.
Yeah, I think about taking this connectome-harmonics, looking at particular brain state, say the state of arousal or state of psychedelia, and then decomposing it down into its particular set of frequencies, and then seeing if you can transpose that decomposition into sound and light, and then subject a baseline person to that sound and light to see if there's a possibility of entraining the brain to produce a similar
so it's like a
subjective
feedback type of loop, kind of a neurofeedback kind of a mechanism. It's actually very interesting because we recently started at least discussing a potential collaboration in order to turn the harmonics that we compute and their activation in the fMRI data into music, actually,
wow.
in the psychedelic state and in the placebo. So hopefully it won't be too long before we create these literal brain songs from psychedelic data sets and also the resting state, and see the difference. But whether that can be used to really induce that state is another extension of that needs to be seen, but it would be definitely very interesting. I mean, we already feel the changes in our mood and state by simply listening to music. So the missing link would be finding the corresponding brain states and trying to activate them in brain activity. But I would even say that by simply listening to music, we're probably doing this kind of thing already. We just don't know how it works in the brain yet.
I wonder if you were to do a study where you create music out of all these different states, including the psychedelic states and resting states, and then have a collection of people who you've gotten sort of metrics on to the level of enjoyment of a psychedelic experience, how experienced they are, etc. Get like a broad range of that, including people who have never taken psychedelics, and then expose them to different sets of sounds at different times in a double-blind way, them nobody knowing who's going to hear what sounds, them maybe not even knowing that they're going to hear psychedelic sounds, and then have them report both what was your subjective experience of, like, during this song, and what was your level of enjoyment of this song, and then see if there's any places where people who trip psychedelics and love tripping psychedelics happen to like certain music more, the music of the psychedelic state more. I mean, I'm just throwing out that possible study, I'd be very interested.
Yeah, it's definitely an interesting idea. I mean, there are rather art projects going on at the moment who turn psychedelic data into music. But that was the discussion that we recently had. How much makeup do you put on that data, and how literal can it be pure data and turn it into music? I think there is still a bit of a playroom there that we can explore, but it would be very interesting to see if that I mean, I would doubt whether the music itself coming from the psychedelic data set would induce psychedelic experiences. That would be quite a shocking finding.
Yeah, right.
But
Yeah.
if it was the case, that would be quite surprising. But it could be, like you suggested, possible to see whether participants who like psychedelic experiences would also like the music that was created based on the brain activity in the psychedelic state. So,
I mean, I know that I started liking Pink Floyd a lot more after I started tripping acid, to be honest. So there's something to that. Now, I want to move on because there's two more pieces, and I don't want to take too much of your time. And they're kind of building into the wild conjecture on the very end, which is that so it's possible that what you've discovered with this harmonic waves might show in time to be some sort of underlying fundamental process at the basis of what we understand to be reality, including our subjective experiences and even the development of the natural world. For example, you've already suggested that there's a relationship between this algorithm that determines harmonic waves and the frequency or like the shape of an animal's coat. So it might be possible to consider that this might be one of the principles underlying microendemic characteristics or microendemic evolution of characteristics, such as like the Galapagos Islands having all these very unique birds and such, and why certain animals although are very related, take very different shape and form in different places around the world. Do you think I'm pushing too far? Is that possible?
Well, if it's possible, I mean, I'd certainly like if it would go even that far. But so thinking about reality, I mean, reality, in a way, we construct reality based on our senses, like the five senses that we have give us certain signals, and then we build a coherent image or coherent description of the reality. Whether this type of representation that we develop, like these connectome-harmonic patterns, are more suitable or more natural or matching certain natural characteristics of that reconstruction of reality, that, I mean, I really wouldn't know. We have to think about it, see how it can be tested, and maybe take it further. But I do like to point out, like you said, and that was the general motivation of testing this harmonic idea on the brain in the first place, that harmonics seem to be universal. They seem to be emerging, like nature seems to be using the very same equation over and over again. So in morphogenesis, in animal coat patterns, and actually the same equation can be seen as to describe the electron orbits, or it describes electromagnetic interaction patterns within a grid of ions, and so on. So it's various different physical phenomena and even biological phenomena seems to be kind of described by more or less the same fundamental principle. And thinking about nature, why should nature reinvent the same thing over and over if it has a certain fundamental principle that is already optimizing something? Why should it say, okay, for birds I'm going to use this principle, for this I'm going to use the different principle, and so on? Rather, it allows us, and I'm glad you did actually pick up on the fact that it's there's a similarity or a shared component in different aspects of the harmonics, that the anatomy of the bird would certainly have like harmonics with different weightings and different adapted to its own shape than a giraffe and the others. But harmonics can be the fundamental principle creating all of these. And if that was so, then there is a chance that what we do about the brain also matches that type of framework. So that still needs to be seen, I think, in the future if we want to talk about it scientifically. But there is this observation of the emergence of harmonics in various different physical and biological natural phenomena. Mm-hmm. And that could be kind of a more encouraging aspect to go further in mm-hmm. the harmonic analysis.
Mm-hmm. Especially, so taking it further, then the same harmonic principles might be responsible for the morphogenesis of different animal species, and that each animal has its own, is its own metal plate. And thus the environment is also its own metal plate, and that they're in some sort of exchange of harmonies, making music together, and that the environment as a whole is its own harmonic standing wave as long as it maintains its integrity over time, such as mm-hmm. the wilds often do. Mm-hmm. Which would, and this is why I'm going way out in the conjecture here, which might suggest that there are particular standing waves in different environments, different specific frequency patterns that are present in different environments. Mm-hmm. Because yes, light, sound, but also perhaps that can modulate brain activity and brainwave entrainment, but perhaps so does electromagnetic fields. And maybe we're in a particular environment, the electromagnetic field is its harmonic standing wave, which then contributes to a subjective change in the person when they're immersed in that environment. Wherein, mm-hmm. if we were to make everything an expression of energy and harmony, the sensations of moisture on the skin, the smell of essential oils, mm-hmm. And the visual imagery of light passing through leaves and the colors of the forest would all be harmonic information, exogenous harmonic influence to a subjective brain state. Then perhaps we could look at why being in nature seems to help people relax compared mm-hmm. to being in the city. And also then extending the idea that when we do certain things, we reinforce the brain to do those things, which creates these valleys for the balls to roll through, and that there are different subjective experiences present for people who live in long-standing concrete jungles compared mm-hmm. to people who might live on Hawaii, for example.
Mm-hmm. No, I really like the perspective in that it provides rather a holistic approach to look at things. Instead of looking at the brain in isolation, what you're suggesting is to look at it, including its interactions with the environment. And it would also include the whole sensations through the body, not only the brain. As neuroscientists, we really tend to focus on brain and just take it as an object in isolation rather. But I do certainly agree that we are becoming more and more aware of the importance of these interactions with the environment and how it actually alters the mood and the state and so on. It would be definitely quite interesting to be able to learn from it more, how our method can be extended to that specifically. That needs some thought, but I think given the fact that it's kind of a fundamental principle emerging in various different natural phenomena, there may be some leeway there. There may be a possibility to look at our experience and our interaction with the environment in a more holistic way. Mm-hmm. And I think it would be definitely quite important and interesting to consider it that way, because now even there are studies pointing out how important it is and how it changes the brain when we spend time in nature, and that's more or less socially where we seem to have dig the hole for ourselves and now looking for ways out in that sense. So it would be a quite interesting perspective to further investigate.
And then add to that why different people have subjective experiences of different places. And then I like to think about the present moment expression of my being is something that has come into existence through some sort of series of causal events across time, and that in any present moment I am my own unique frequency pattern simply by nature of being myself. And that when I interact with, say, the frequency patterns or standing waves of my external environment, I'm not experiencing the raw reality of that external environment, nor am I experiencing the raw reality of my history so much as I'm experiencing a direct encounter of the interference patterns between me, and the outside world, which sometimes are less harmonic than other times. And again, I'm just going off on wild conjecture because I can, but I'm happy for you to talk to that.
It's I mean, to speculate on that, if we take the phenomenon of resonance, resonance would only happen between frequencies that match each other. So for example, in the metal plate example, if we stimulate the plate with anything other than its own set of natural frequencies, it will not resonate. The whole energy is going to just dissipate and create no patterns whatsoever. So in that sense, there is a kind of similarity or analogy in, let's imagine, like our own resonance frequencies and the environment's resonance frequencies, and we would only interact or get something from the environment if it did match our own natural frequencies. Otherwise it would just dissipate, and the impulse would just get lost. It wouldn't stay in that state. That could be one way of maybe thinking about our interactions, but I'm really speculating right now, not necessarily talking about the scientific framework, but rather a way of seeing things. So if we had certain natural frequencies in our brain activity or in our whole body and our being, the interaction could match the resonance between us and the environment in a way.
Or other people.
Yeah.
Well, thanks for taking this long step into wild speculation with me. Selen, where can people find out more about your work? Where can they follow your research? And I don't know if there's still crowdfunding for psychedelic research or what, but how can people best learn about what you're doing and support what you're doing?
Well, thank you for this, actually. I think for my research, the most compact link to describe all of the latest projects and publications and talks would be my website. It's Selen, Selen Atasoy Atasoy.com. I also try to report on Twitter as much as I can the studies that I find interesting, or also our own studies. So that's all on my website as well. Currently, I'm at the University of Oxford at Department of Psychiatry. But in academia, we do have a trail rather. So I think the most current information would be on my website.
Excellent. Well, I'll make sure links to that are contained in the show notes of this episode at jameswjesso.com. And
thank you.
I also just realized I've been pronouncing your name incorrectly this whole interview, so sorry about that.
No problem.
Thank you very much for being on the show.
Thank you for inviting me. It was a great pleasure.
And cut.
Thank you everyone for tuning into this episode of Adventures Through the Mind. I would absolutely love it if you gave it a thumbs up on YouTube, a like, or a share on whatever social media platform you can. This podcast is small and it grows of word of mouth, and I actually think word of mouth is probably the best. I'm not really sure how I feel about giving money to large data mining companies that give us a free product in exchange for harvesting our interests and our tendencies, and basically profiling us and our behavior so that we could be sold to, even though that which I would be selling, air quotes, to you would be something that I think has a lot of value, and probably you would think has a lot of value, and you would be glad to be
exposed to it through these, advertising platforms like Facebook or Google or Instagram or whatever, I still feel a little weird about giving those companies money. So word of mouth is excellent. Thank you very much for telling a friend. If you would like to support the show financially, there's a few ways that you can do it. You could become my patron on Patreon, which is a type of subscription-esque platform where you pledge a certain amount to me, and then depending on how much you pledge, you get some cool bonus stuff, and I get to reliably invest my time and money into the podcast because you believe in me and I believe in what we're doing and we're all in it together, and it's a exclusive community, and it would be great. So you can become my patron by heading to patreon.com/JamesWJesso. You could also leave me a one-time PayPal or cryptocurrency donation, or you could buy some merch. Sort of just like the other thing that I do with my life is I have these books that I've written on psilocybin, decomposing the shadow and the true light of darkness. You could buy copies of those. That would be an excellent way to support the podcast and get yourself, I think, a wicked couple of books. You could also buy Some Blotter Art, which I had exclusively produced for the podcast here, limited edition of 100. They are not containing any LSD, although they look like they should have LSD on it. They're for your wall or your fridge, preferably a frame, but not for getting high off of, as much as one day it might be nice to get, it would be cool to get high off LSD that had a picture of my logo on it. That's not the intention, and they're definitely totally legal across all international boundaries. That's it. Thanks for tuning in. And if you haven't already been inspired by one of the other things that I offered that you could do, the calls to action, you could follow me on social media, Instagram, Facebook, and Twitter @JamesWJesso. Thanks a lot, and I'll see you on the next episode. Take care.